Hello everyone, welcome to our video for math learning number 3. Our conceptual question for this learning is, how do different visual representations help us compare, analyze, and predict the outcomes? Just like in the previous learnings, you must be able to answer this question at the end and provide evidences as well. So here are your math words. Make sure that you now have your notebooks so that you can write down some notes. Make sure that you understand these words later on. Okay, so let's get started. First, we have here a situation wherein you are going to flip 2 coins. For a change, you will be using 2 tools, even if it's the same as it's coin, but here you are using coins. In the previous video, we talked about using the coin, but there's only 1 coin. We also talk about using the spinner, but there's only 1 spinner. Okay, so here in this situation, we want to find out the probability of using these 2 coins, and then that you will get 2 heads. And then the other problem is that what is the probability of getting 1 head and 1 tail? First thing that we need to find out is that how many possible outcomes are we going to have? So for this one, we will have many different ways on trying to get the possible outcomes. So I'm going to show you first, the first tool that you can use is to write down an organized list. Come up with an organized list. Okay, so let's do that. So we will think of here, it could be that a tail and a tail will come out. So on the left side, I'm showing you inside my head, I'm thinking the left side represents the first coin, and then on the right side is the second coin. So it could be a tail and a tail, and then it could be also that the first coin is still a tail, and then the second one now is head. Now on the third possibility, it could be now that the first coin could have head and the second coin will have tail, and then a head and a head. By doing an organized list, it gives us the possible values, and in this case we have 4 possible outcomes. If we have this, then we can now get the probability of getting 2 heads. In this scenario, we can see that it only happens 1 time out of 4 possible outcomes. So we can write the probability of getting 2 heads is equal to 1 out of 4. Okay. How about the probability of getting a head and a tail? By looking at your organized list, you can see that there are it can happen 2 times when you have a tail and a head and a head and a tail. So now we can write the probability as 2 out of 4, 4 being your 4 possible outcomes. And we can simplify the fraction, and 2 out of 4 is the same as 1/2, or you can write it in decimal, which is 0.5 or 50%. Okay. Another way of coming the possible outcome is by making a table. This may work if you have a lot of tools probably, and so making a list you will have to write a lot of outcomes. So with the table, it helps you think better. Okay, so here I listed on vertically for the first coin, a head and a tail, and then vertically here on top of the table is coin 1. By having this table, then you can have this T and T over here, they meet, so tail and tail. Head and head, I'm just copying the one on top and on the side, and so here on this spot I will have a head and a tail, and then on this spot is tail and a head. I still have 4 possible outcomes, same as what we have in the previous slide. Okay, this is just another way. Okay, now talking about the probabilities. Previously, if we have 1 coin, we know that the probability of getting a head is 1/2, and then getting a on the second coin is another half. Okay, so if this is a case, finding 2 heads is 1/4. I'd like you to take a look at this and hopefully you get a connection. Can you spot the link of having 1/2 and 1/2? How do you get to 1/4? Okay, so think. You may stop the video and so you can take a closer look and then just play it again when you have an idea of what can it be. Okay, to continue, just before we start giving you the answer for the connection, I would like to mention that for this 2 heads, because you have multiple tools or that multiple times that it's going to happen, we call this as compound probability. The word compound probability is mentioned as one of the words that you need to understand at the beginning of this video. And then if you have one tool or that you only need to get a probability of a one-time event, it is a simple probability. I think this is easy to remember. You have 1, so you need it one time, simple probability, and then if you have to get many probabilities, then it's compound. But you also have to watch, there's a difference, because here is that it's the probability of the first one is not going to affect the result of the second probability. Okay, so if you have this, it's what we call the end rule. So to get it, it's you just multiply the simple probabilities of simple events and you get the result of the compound probability. I'll give you more example on that. Okay, so now we move on to the use of tree diagrams. I showed you how to make a list. I also showed you how to use a table. This time I'm going to show you how to use a tree diagram so that you know what is how to represent your probability using a tree diagram. Okay. And then on the way to looking at the tree diagram, we're also going to use multiplication just as I have shown it to you. Okay, so let's go back to the 2 coins. Okay, let's use tree diagram to represent the problem about the 2 coins, and we have to get the probability of 2 heads. So on the first branch of the tree represents the first coin. So the first coin can only have the outcome heads and tails. And each event will get the probability of 1/2 or 50%. Now we write and draw the branches once again. Once you have tossed the coin first time, now it's the second coin. The second coin again by the way, just remember for each branch, if you add the probability, it will always be equal to 1. Okay, let's continue. The second branch represents the second coin. The second coin, again, each simple event for the coin 2, the head and the tail, still each time it gets half. Okay, and then here it will again branch out, heads and tails, and then a 1/2 and 1/2. You see, for each branch, it's always equal to 1 over here. Okay, and then you can count downwards, and this is the number of total outcomes. You have 1, 2, 3, 4. Okay, so now we can read this sideways or horizontally. So I go head and ahead, then you will have the probability of head and head is 1/2 times 1/2 will give you 1/4. Then you can also go head and tails. Probability of head and tails is 1/2 multiplied by half, which is 1/4. Tails and head is 1/2 multiplied by 1/2, same thing, and your tail and tail. So now we can answer the head and head, which is 1/4. Okay, as you know, you just have to multiply along the branches and you will get the probability. Okay, so now let's have a new problem. How about if you have a bag of counters? It contains 3 blue and 7 you are going to pick one counter without looking, and then after you have picked one counter, you have to return it back to the bag, and we want to find out the probability that you pick one red and one blue. We're going to use a tree diagram here. So I have two colors, so the first one will represent the first pick. Okay, so red and blue. Red we have 7 red, so that means the probability of getting red is 7 out of 10. And then blue, you have 3 blues, and then the total of 10 counters, so that's 3 out of 10. Now take a look on this first branch. If we add 7 tenths plus 3 tenths, you will get 10 out of 10, which is 100 or 1. It's always like that. Okay, now we move to the second pick. Remember that we return back the first one. So again, your bag will still have 10 counters. And you will still have 7 red and 3 blues. It's going to be the same on the second one. Okay. And now, let's get the probability of getting a red and a red by multiplying each simple probability. Same thing with red and blue, multiplied its probability, and then blue and red over there, and a blue and a blue. But on this problem, we want to find out what's the probability of getting a red and a blue. So if I take a look at over here, we need probability of red and blue and the probability of blue and red. This is what we want. So these two, we can now add them together to be able to solve the problem of what is the probability of getting one red and one blue. Okay. If this is not so clear to you, I am going to show you another problem. On this problem though, you will have a similar problem like this in your worksheet, so you may want to listen. And also same thing with if you want to do the level of 2 stars problem of the paper, scissors and stone activity. Okay, so here's you place a bet on the outcome of 2 football matches. The probability of winning the first match is 1 out of 10, and the probability of winning the second match is 3 tenths. So I made the tree diagram here, but I did not write all the information. We know that the first match, the probability of winning is 1/10. Okay, remember that I said that for each branch, it's always equal to 1. So if you have a probability of 10% in winning, that means that you have 90% of losing, right? So that is 9 out of 10. Okay. Now moving on to the second match. If the probability is 3 out of 10 for winning, or 30%, that means that the probability of losing that bet is 70%. It's always 100 or equal to 1. Okay, so I'm going to complete the tree diagram. Okay, so it says here, calculate the probability of me winning both bets. So we want a win-win. So win-win is this path, 1/10 and 3/10. But we say that whenever it's an AND or compound, we need to multiply the probabilities of the simple events. So that will be 3 out of 10 multiplied by 1 out of 10. So the probability of winning both matches will be 3 out of 100 or 3%. Okay, so very low. Now we want to get the probability of winning at least one time. You could win the first time and lose the second time, or lose the first time and win the second time. So we have 2 scenarios here. So for the first, win and lose is 1/10 multiplied by 7/10. So we will have 7 out of 100. And then on the second scenario, you will lose the first time, which is 9/10, and then win on the second time, 3 out of 10, which will give us 27 out of 100. Now, after that, we are not done yet. We need to add these two. So 7 out of 100 plus 27 out of 100 is 34 out of 100. So you have 34% of winning one time. Okay, so if this is confusing, watch this video again, and then, or you can set an appointment with Miss Kim or myself, and then we can talk about this again. Okay, so the thing that you need to do next is to look at your choice board and decide which one you would like to use as to show us the evidence of your learning. And that's it. Bye.